Figured I'd hop on a little early, check my mic and everything. Make sure it doesn't sound like ass. Check, check, 1, 2. Check, check, 1, 2. Buckle my shoe. Alright, that's good. The echo is going to get crazy if I do that much longer. Okay. Let's actually, let's pop this out. And let's get ready. Let's get ready for today. Can't believe I've made it to day 19. Gotten a lot of help, but still proud of myself. Oh, let's turn Copilot off. Got some failing tests somewhere. What is this for? Oh, yeah, the one that's supposed to fail. Great. All right. I have a feeling today's gonna be a doozy. Yesterday was just too chill. What do I think it's gonna be today? AOC 10 years. Wow, man. 7 more problems. Oh, 7 more problems. And then I can sleep again. Alright. Let's knock this one out. Okay, here we go. Today the historians take you up to the hot springs on Gear Island. Very suspiciously, absolutely nothing goes wrong as they begin their careful search of the vast fields of helixes. Could this finally be your chance to visit the onsen next door? I love onsens. Only one way to find out. After a brief conversation with the reception staff at the onsen front desk, you discover that you don't have the right kind of money to pay the admission fee. However, before you can leave, the staff get your attention. Huh? Oh, before the staff get your attention. Typo. Apparently they've heard about how you've helped at the hot springs, and they're willing to make a deal. If you can simply help them arrange their towels, they'll let you in for free. Okay, I can do that. I can arrange some towels. Every towel at this onsen is marked with a pattern of colored stripes. There are only a few patterns, but for any particular pattern, the staff can get you as many towels with that pattern as you need. Each stripe can be white, blue, black, red, or green. So a towel with a pattern GGR would be green stripe and a red stripe. Wait, what? Oh, green stripe, and a red stripe, in that order. You can't reserve a pattern. Oh, you can't reverse a pattern by flipping a towel upside down, as that would cause the onsen logo to face the wrong way. The official onsen branding expert has produced a list of designs, each a long sequence of stripe colors, that they would like to be able to display. You can use any towels you want, but all the towels' stripes must exactly match the desired design. So to display the design RGRGR, you could use two RG towels and then an R towel and RGR towel and then a GR towel, or even a single massive RGRGR towel, assuming such towel patterns were actually available. To start, collect together all of the available towel patterns and the list of desired designs, your puzzle input, for example. Okay. The first line indicates the available towel patterns, and then these are the desired towel patterns. In this example, the Onsen has unlimited towels with a single red stripe, unlimited towels with that, so there we have unlimited towels of each of these. After the blank line, the remaining lines each describe a design the Onsen would like to be able to display. In this example, the first design, BRWRR, indicates that they want, black, red, white, two reds, in that order. Not all designs will be possible with the available towels. In the above example, the designs are possible or impossible as follows. That one can be made. This one can be made. This one can be made. That one is impossible. Right. And this one's impossible down here. In this example, 6 of the 8 designs are possible with the available towel patterns. To get into the Onsen as soon as possible, consult your list of towel patterns and desired designs carefully. How many designs are possible? Okay. Let's find out. Okay, so we have some towel patterns here. I should really step up my game and start using the API to get these inputs, huh? Okay. Let's close all these editors. Okay. So the first thing we need to do is get the available towel patterns. How should I do this? Let's think about how to do this first. So one way I could do this is looking at the desired pattern. This is like really dumb brute force way. Like get all combinations of the available towels that give me that same length and see if it matches. I could speed this up by checking that, like, the first selection I take from the available towels, at least the desired pattern starts with that one. That would be a way to speed that up, and then I could just I could just use strings and then add the next one. Yeah, so let's just get our So I take my desired pattern and then I could just put together all the combinations of the. Let's just start with that. That's easy. Probably gonna be mad slow. How big is the input today? It's pretty large. It's pretty big. How many available patterns we have? We have a lot. Let's see how long that is. So let's get that in a list of strings. Available towels equals, let's just get the parts. Data.trim .split, split it by a double new line, and then the available towels is going to be arrays.stream parts to 0 dot split by a space and a comma, or a comma and a space, and then map each one of those little guys. Actually, I can just collect it from there, right? So that's our available towels. And the desired patterns is going to be arrays dot stream parts 1 dot split by new line this time, and then yeah, just collect them. So let's see how, let's see what like the length of those are. Available towels dot size, and let's see how big the desired patterns. That part really doesn't matter much, but yeah, let's see. So if I was to try and brute force it, I think it's probably too big, because even these individual patterns are pretty large. So let's try like a naive solution here. So Boolean is possible pattern, and let's take the list of available towels and let's also take the desired pattern. And one way we could do this we could just go while might be really bad. Why don't I just use a string for now? If it's like super slow, and let's just go for towel and available towels if result plus towel, let's say if not, first let's do this, if result plus towel, let's do this. And if that candidate dot length is greater than the desired dot length, or candidate dot, if it's not empty and the desired dot starts with and it's not empty, wait. And it's not empty and the desired one starts with that result, or starts with the candidate, then we'll say result plus equals that towel. This is actually not gonna work, is it? I could do like a combinatorics kind of thing, like choose this towel or don't choose this towel. Why don't we try that? We'll take our desired and if cur dot length is greater than cur or cur dot equals desired return cur, so greater than or equal to, oh, what am I doing? Greater than or equal to cur dot length, sorry, desired dot length. Then we want to return that one. Otherwise, let's grab this one only if oh wait, we're missing something here. So if cur plus, oh yeah, also if I is greater than or equal to so the candidate is going to be the cur plus the available dot get I, and we either take it or we don't. So what we're only going to take it if can dot length is less than or equal to desired.length and desired.starts with the candidate. Let's do make combo candidate desired available I+1. And then we can also just choose not to take this one, and it would just be cur desired available I+1. I think that would work. Oh yeah. Wait. Wait. Take or not take. If we take it, my issue here is the return type. So 2 recursive calls. Or should I loop through? No. This one's weird. If result 1, I don't really know what I'm doing. Result 1 dot equals desired. Shit. I don't think this is gonna work. Yeah, I don't know about that. So then I would just this possible pattern. Return, make a combo, the current string, desired available tals 0, and then up here I'd just be like loop through each desired pattern. Desired list of available tiles. Let's try that, I guess. This should return 6, hopefully. No. So sometimes they're empty. Looks like we're almost doing something right. Why don't I return a Boolean from here? Yeah, why don't I do that? Boolean. And if I is greater than first, let's see if so if it equals, this will return true. If I is greater than or equal to the available dot size, or cur dot length is greater than or equal to desired dot size or length, return false, and then we would just return make combo cur plus available.get I desired I plus 1 or make combo, we don't take it. Yep. Cur try that. Nope. Huh. I guess also we could do or not desired dot starts with cur why wouldn't this work? So we're not getting any of them? Oh wait, what? Oh, 1. We should be getting 6. Let's think about this. So cur starts as an empty string. We add the first guy, or we don't add the first guy, and we increment I. I actually don't know why this wouldn't work. So I should be getting into, well, don't really know. Like R. What? Do I have them backwards? No. Oh, the problem is that I can repeat them. So there's actually going to be 3 recursive calls. So I can take it and increment I, or wouldn't this? Yeah, or I could take it and not increment I. That's right. I could take it and not increment I. Missing a recursive call there. Now I get 0. Oh, that's because I'm not doing it. Now I get 2. So I can choose to take it and increment, or I can choose to just take it and not increment, or I can choose to just not take it. Let me check my base cases here. If cur.dot equals desired, return true. Good. If the available, or sorry, if I is greater than or equal to the available size, or cur.dot length is greater than or equal to the desired dot length, or the desired one does not start with cur, return false. Wait, why do I only see, well, I should, yeah, they're all there. And which ones were supposed to be possible again? All of them except for the UBWA and the BBR GWB. Now, why wouldn't this work? I'm just really screwing this up. Cur.dot equals desired. Return true. Y is greater than available size. Wait. I'm getting 2. Am I like inverting my answer? Whoops. So I should see 6, but I really do only see 2. I know that should be right. What am I missing here? Oh. I think I'm missing the fact that I can go back to the beginning of the array. So why don't we do this? Let's just stop only if that's what I'm missing. So if current length is greater than or that, and let's cycle through. Let's cycle through them. So I plus 1 mod by available dot size. Yeah, feel good about that. No, Stack Overflow. Oh right, yeah, that won't work. Shit. Dang. Well, then in this case, well, how will I be able to stop? Yeah, because sometimes you want to go back to some ones that you've already chosen. So I could change this to be like, if it's equal, we're good. If cur.length is greater than, or does it start with, get out, maybe, and then just be like, cur plus available dot get I desired available. Now we don't need this. I feel like that might work. It's actually like a, is it a permutation? I don't know. There it is. Alright, sweet. Yes. Let's try it with the real one now. See how slow it is? Not too bad. 371. Hope that's right. Yes. The staff don't really like some of the tile arrangements you came up with. To avoid an endless cycle of tile rearrangement, maybe you should just give them every possible option. Oh gosh. Here are all the different ways the above examples designs can be made. Okay, so that can be made 2 different ways. That can be made 1 way. That could be made 4 different ways. That could be made 6 different ways. Can be made with that. Blah, blah, blah. The ones that are impossible are still impossible. Now I just need to add up the all possible ways to make each one. Okay. Slightly different problem here. So let's just do a little copy paste first and see. So this time we're going to count how many possible ways we can make this guy. So let's keep track of a count. Return count. So this will be an int. What's that? Return count. Well, no, just return 1 actually. So if it equals desired, return 1. If it's, you know, if it's a no-go, return 0. And then kind of the same thing here. This one's a bit different. So I have this desired and I want to know how many ways can I make that. So okay, I think now I want to take or not take. Now I want to take result plus equals this. If I do a recursive call where I don't add anything, nothing happens. So I'll return this and then not take. You know what? Actually, I think it'd be almost the same as this. Or it could be wrong. Turn 1, turn 0. Or I think result plus equals this. Maybe. What? Oh yeah. I don't know about this one. So we should get 16 with the sample. Yes. It's gonna be too slow. Okay, I might have to do like some... How can I speed this up? We got 400 to go through, and we're not even through the first one. I think it's because we're checking all combinations. Okay, is there a way to do dynamic programming here? Yes. Yes, there totally is. So I'm going to map, what am I going to map here? How am I going to map this with dynamic programming? Let's see, I have cur. I have like the candidate and I have an index. Is that enough to do it? Candidate index. Wait. No, I really don't know. It is super slow though, right? Not gonna happen like this. Definitely not gonna happen like this. To make all basically checking all combos. Is there a way I could cut out earlier maybe? I think I could use dynamic programming somehow. So we got a lot of little pieces that I'm like making over and over again in here. For sure. Probably. So for dynamic programming to be possible, what if I, no, it's taking way too long. So I could, dang. I gotta get clever with this one, maybe. So I have all these strings here. Some of them are true, probably. I mean, most likely. I'm assuming. Some of these are true. And is there a way I can store like little pieces of them so I don't have to make them again? Really interesting. Come on, man. Hub. Let me see if there's like maybe some general knowledge that would help. It's not. Is it combos or is it permutations? It's combinations. Well, the order matters though, so I think it's permutations. No, but it's like... No, it's like, no, actually, it's like, yeah, it's combinations. No, I don't think that's analogous. It's like... What if I... how many... Oh my gosh. Damn. Okay, this one's gotta be easy. I'm just being dumb. I'm just being a little silly goose. There's something I don't know. Okay, I'm getting help. I need help. Help me. Come with me, and we'll see. This one must be not that hard, and I'm just being dumb. Yeah, this one, it must not be that hard. I just don't understand how to DP. Oh. Wait. Huh? Oh. Okay, so instead of actually adding it to this, and we actually don't need to do this check here. Yeah, we don't need to do that check here. Let's do that check here, because if it starts with that, if desired dot starts with our current string, we don't actually need to add the next available word to it. We just need to actually chop off part of, we need to make the problem smaller as we go to make dynamic programming possible. So we need to actually chop off a part of the desired that we're looking for. So we'll say substring, and we're going to go from cur.length, yeah, cur.length, and then don't actually add it. Now our base case can be a little different. Well, no, because this will handle that. The length is not going to go over. The length is not going to even going to go. It's not even going to go over anymore. Or would it? No. And now we'll map string to Boolean. We should do a Boolean array. No. Yeah, make a map, because we don't know how big it's going to be. So we're going to map strings to Boolean. Give me the big one. What? And we can first just check if map.contains key desired return 1, or if cur.equals, no, if cur.equals desired, put it in there. Map.put desired true, and then down here I think that's it. Oh, okay, what's causing that? Oh yeah, if desired, oh, that's not gonna work anymore. So we need to say if desired dot length equals 0. Zero. If desired dot starts with cur. So we need to focus on making desired smaller. I'm just not doing it correctly. Oh, if desired starts with, that's right. available.get I. We actually don't even need this cur thing anymore. We don't even need that anymore. I think okay, so let's actually just loop by value instead of by index for word in available if desired dot starts with word, then result plus equals make combo desired dot substring desired dot substring, dang it, come on, word dot length, yes, like that. Oh, we also need to check. Yeah, we did check. Okay. Okay. Oh, no, wait, what? Dang it. Why is that different than mine? Oh. What am I doing? I should be mapping an integer here, the sum of the thing. Yeah, we're not doing Boolean anymore. So if it's in there, return it. Map.getDesired. And we need to... Okay. Equals 0. If that is the case, then we need to say result equals 1. And for the word is yeah, and then at the end map the result. desired with result. That should do what I want. Boom. Oh, overflowed. Crap. So yeah, make this a long. It's a long boy. This too. Probably just that part actually, but whatever, just be safe. Okay. That's big. That's big. Is that big? That's a big fucking number. Okay, we did it. I was just being a big dum-dum. I knew I had to use dynamic programming. I just couldn't figure it out. I looked at Jonathan Paulson's code again. Well, that's it for day 19. Also, not that crazy. I'm kind of chilling. Thanks for watching.